มีประมาณใส่อยู่ในอะไรคนแรกไม่ได้ย้อนเลยเพราะว่าสิ่งนี้คิดเอง
Daya ganun.
There tomorrow month off right?
Oo. Level siya.
Hah? Yan.
Siya Y B ah. B siya.
B or H ka rin?
Decipher what he really wants.
H is 25 minutes.
So for this problem, what's the value of C? You have your height being 25 millimeters. And then you have your C to be 12.5. And what about A? You're looking at this one to be 10% of, or the total for this one will be 20% of this whole height. So 10% each. So if that's 10% each, so that's 2.5. So what do we have here? So this one is in millimeters, so please don't be confused. So that will be in millimeter. What do we have here? So 2.5, 2.5. Oh, 10%. 20% is 5 millimeters. So we have this one to be 10 and 10, yes? Correct me if I'm wrong. This will be negative 10. And that's minus 12.5.
Yeah, he's saying that this is the...
Again, you may want to be consistent with the units. This one will be your yield strength. Well, I don't know why the course coordinator would want this one to be your symbol, but this one will be your yield strength. So this will be 220, be careful with the units, Newton per millimeter square. I changed that to 220 already, sorry. The reason why I changed this one earlier is to prove that there's a yield. So I'm sorry for that. So what is your B? What is your base? So that's 20 millimeters, so that's 0.02 meters. The reason I'm not converting this one here yet, I'm not converting this one to meters squared to Pascal is because I have this one to be millimeters squared, so I will just cancel out anyway. But I have this one to be meter, so that my resulting moment will be Newton meter. So what do we have for this one here? C squared, that will be 12.5 squared minus 1/3 of that 10 millimeters squared. So my value here will be in millimeters squared. So take it out, I will be cancelling that millimeter squared, so that my answer here will be in Newton meter. So that will be my moment. Well, nobody's stopping you from converting or using Pascal. So if that's 220 megapascal, then this will be 220 times 10 to the 6 Pascal. And this will be in meters, so you can convert this one in meter as well. So your Pascal will be in Newton per, what am I saying? So if you want this one to be in Pascal, so you can have this one to be 220 times 10 to the 6 Pascal or Newton per meter squared, not a problem. You can have this one to be 0.02 meter, that's your base. This one will be 12.5, sorry, 0.0125 squared minus 1/3 times 0.01 squared. The unit for this one will be in meter squared. So that if you check your units, this meter squared will cancel out. You will end up having Newton meter as the unit for your moment. So here I just use the millimeters here, and here I just use the meters. So what's my solution, or what's my answer here?
Let's say that it's the same.
So what's my answer here? Anybody? 540? Point 8. Got it? Now I would like to add more. What if I want to calculate for the moment or for the stress? Just out of curiosity, if I want to calculate my stress, then this will be still moment my over I. Yes? Still a big problem. So if I want to solve for the stress acting on my material or my beam, since it's a big problem, stress is equal to my over I. So, okay, any questions here? What I'm going to do, since we didn't discuss this much, this one is, well, this problem shows that you have a similar problem here, but your cross-section is 4 centimeters squared. Stress distribution, applied moment causes the plastic cells to extend over half of the cross-section. Okay, so this is the solution here. And then what I'm going to do is send this one to you to have a look at it first. So try to use this concept and solve question number 3. So if you try to look at it, most of the solutions have been solved by you as well. Together we solved this one. So have that confidence that you will be able to understand what's in your notes. Okay? I'm going to send this one, I'll email it to you so that you will be able to have a look. So, next meeting, any topics? I'm going to look at pressure vessels. So, try to prepare. We'll look at pressure vessels. If needed be, then I will be discussing the derivation. If needed, that is, but if not, then I won't. But some of you have already inquired about the derivations or probably conjugate of that derivation. And of course, look at the thin, thick-walled pressure vessel problems. So this is okay. With time, we still allow a lot of time for tutorials and mock exams, whatever that is. Any suggestions for topics to cover next week? discuss. If you have any suggestions,
We discuss also with
please suggest any topics that you think is not clear here in your notes, then we'll try to discuss further. So week 8, week 9, week 10, probably we don't have to meet the week 11 really. Any questions? So I hope you have already a clear understanding, maybe not so clear, but I hope you have already a clear understanding between elasticity, plasticity, using those constitutive equations, using those parameters. So I hope you have an understanding with this one and a bit of this limit state problem that we have solved earlier. Limit state meaning this one here. So if you have that understanding, then that's good. Next meeting we'll look at pressure vessels, so please prepare, and next meeting I'll try to look into something that we can discuss. If you have any suggestion for week 9 and week 10, please send me an email. I would really recommend you to suggest, please, as I really do not know which one is still not clear to you. Alright? Okay, so